This is worksheet 4 of the factor label packet, and in this worksheet we are going to learn how to put numbers in something called scientific notation. Again, this is really a math skill, and some of you may have learned this in a math class in the past. So the whole idea of scientific notation is that it is a way for us to write very large or very, very small numbers more conveniently, right? When we have really large numbers or really small numbers, it's often inconvenient to write them because there are a lot of zeros involved. So if you look at the examples here, the first three show large numbers, right? Particularly this first one, you've got a whole lot of zeros involved. And if you have to write a whole lot of large numbers like this, or put this many large numbers into a calculator, it can become kind of tedious. The same goes for really small numbers like we have down here that are less than 1. You end up with a whole lot of zeros, and particularly for a teacher trying to check these on homework or a test, it makes you kind of go cross-eyed trying to count the zeros. So what we're going to do is we are going to convert these really large numbers into numbers multiplied by 10, and that 10 is then going to be raised to an exponent. So the exponent would be the small number, like the 6 here, right? And so you might notice a pattern here. If you look at the first three numbers, the 2,500,000, the 200, and the 3,850, when we put them in scientific notation, they all have positive exponents. And for the smaller numbers down here at the bottom, the 0.00025 and the 0.0375, they both have negative exponents. All right, so what we're going to learn is how to put very, very large or very, very small numbers into scientific notation. And we're learning this because from here on out, I'm expecting your final answers on factor label type problems to be expressed in scientific notation. And that will go for your quiz on this unit as well. All right, so to put numbers in scientific notation, you are going to place a new decimal after the first digit of the number. And that is going to allow you to make a new number that is between 1 and 9, rather than the very large or very small number you've been given. Then you're going to count back to where the old original decimal place was. And it's important that you count from the new decimal place back to the old decimal place, because the direction that you are moving as you do that is going to tell you if your exponent is going to be a positive or a negative number. So if this seems vague, hopefully an example will clarify. We will look at the first example here, problem number 1, and I'm going to zoom in so that I have space to write. You should write with me. You can write onto the worksheet itself, or you can write onto a separate sheet of paper if that gives you more room. So here's problem number 1. Now, it's interesting with these really big numbers, often we don't see a decimal place. So if you don't see the old decimal place, it's always farthest to the right. Okay, if you were imagining a very generous person writing you a check for $9 trillion like we have here, they would indicate, right, the decimal place and put some more zeros after to suggest that they're not giving you a penny beyond the $9 trillion. So even if we don't write it, the decimal's way over to the right. Okay, so that's our old decimal. Our new decimal, we are going to place to the right of the first digit. right? In other words, we're going to put the new decimal wherever we need to put it to make this a number between 1 and 9. So with this number, if I put the decimal place where I just placed it, that actually makes the number 9, right? And now, direction is important. I am going to walk from my new decimal place back to my old, and I am going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have moved my decimal 9 spaces to the right. Okay, so the direction, as I said, matters. Imagine that this were a number line, right? I've moved to the right, which on a traditional number line is in the positive direction. Yes, whereas had I moved to the left, it would be in the negative direction. So because I moved 9 spaces in the positive direction, when I rewrite my number, I write it as my number between 1 and 9, 9.0, and I don't need to write all the extra zeros. That's the whole benefit of the scientific notation. And then I'm always going to multiply by 10 raised to an exponent. And in this case, because I moved 9 spaces to the right, my exponent will be a positive 9. Yeah? All right, so when you start doing this with factor label problems, you'll have units. For now, you don't, so that's your final answer. Okay, so if I zoom back in, put ourselves back on this page, right? That was a very large number that we turned into scientific notation, and so the exponent was positive. If I go back to problem 2, right? On problem 2, I now have a number that is less than 1. So I'm still going to use the same general method. Here I can see where my old decimal place is, so that's nice. I don't have to bother with trying to investigate where that actually is. I'm going to put a new decimal where I would need to place it to make this a number between 1 and 10. So, excuse me, 1 and 9. So if I place the decimal between the 2 and the 8, I get 2.85, which is between 1 and 9. And now I'm going to walk from my new decimal back to my old decimal. Remember, the direction is important. 1, 2. All right, so I have walked 2 spaces, and this time I walked in the negative direction, right? Because if this were a number line, going to the left would be the negative direction. So when I rewrite my answer, I'm going to write in scientific notation that I have 2.85 times 10 to the negative 2. Okay? Notice I always have times 10 to some exponent. That's the scientific notation. All right. So you will finish up the rest of these problems here in class, but we need to go down to the other thing, the other direction. Okay? There are going to be times when you are going to be given a number in scientific notation, or maybe your calculator produces a number in scientific notation, and you need to be able to put it back into an ordinary, not scientific notation number. So really, we're just doing the reverse of what we did in problems 1 through 10. So, to convert, right, you simply move the decimal, the number of places indicated by the exponent. So the exponent is going to give you a lot of information in this case. So I'm going to zoom in on number 11 here, and you should be writing this with me as I write it. Okay. So in problem 11, I have my number in scientific notation times 10 raised to a power. So we need to really focus on that power. That exponent, or power, is a positive 3, okay? So you need to remember that positive means this is representing a big number, while on the other hand, negative would mean it's representing a small number, a number less than 1. So I can kind of just think common sense here. My exponent of 3 means that I need to move my decimal place 3 places, and because it's positive, I need to move it in the direction that's going to make a big number. And most of us can usually think that one through without having to memorize if that's to the left or to the right. Yeah? So if I move my exponent, or excuse me, if I move my decimal 1, 2, 3 places to the right, it's going to make a bigger number. Now, when I moved around the 5, that was fine, okay? Then when I moved the next 2 spaces, those spaces are currently empty, so I need to fill them to hold the space with zeros. So when I rewrite this so it's easier to look at, I have 6,500 as my final answer. Okay? So while we're here, we can practice number 12, which is a little bit different than the first problem, problem 11, because this time we have a negative exponent. So we're still going to move the decimal as many places as the exponent tells us, in this case 2 places. But this time, because it's a negative exponent, remember, negative means a small number. So most of us can kind of common sense this one through and realize that we are going to need to move to the left to create a smaller number. So 1, 2 spaces to the left. As I move around the 2, I'm fine, but when I move my second space, I need to fill that space or hold it with a 0. So I rewrite this, and I have 0.0281. So this number that was multiplied by a negative exponent is actually a number that is small, less than 1. And that's my final answer. So when you guys come to class, you are going to be practicing by completing problems 1 through 20. And then down at the bottom, problems 21 through 30, you're actually going to go back to doing factor label problems. Okay, so 21 through 30 are really worksheet 2 and 3 style problems where you set up a picket fence and cancel out your units. But the difference here is that the final answer is going to now need to end up in scientific notation, right? So express your final answer in scientific notation, and because factor label takes some space, these, unlike 1 through 20, must be on a separate sheet of paper. So hopefully now you have a better understanding of scientific notation.